You believe the universe had a beginning, and most people accept that much without giving it a second thought. But there is a question hiding behind that belief that almost nobody takes seriously, and I want you to sit with it for a moment. The question is, what happened before the beginning? What caused the Big Bang? And who or what lit the fuse? Years ago, I received an invitation to a conference on cosmology at the Vatican, where scientists from around the world had gathered to discuss the origin of the universe. At the end of the conference, the participants were granted an audience with the Pope, and he told us that it was perfectly acceptable to study the evolution of the universe after the Big Bang, but that we should not inquire into the Big Bang itself. That was the moment of creation, he said, and that was the work of God. I remember feeling relieved that he did not know the subject of the paper I had just presented, because my paper suggested that the universe had no beginning and no moment of creation at all. That paper, and the decades of work that followed, led me to a conclusion so strange that most people reject it on emotional grounds alone. The universe did not need a cause, it did not need a creator, and it did not need anything outside itself. It created itself from nothing, and it did so necessarily, not as a miracle or a mystery, but as a direct consequence of the laws of physics. If that makes you uncomfortable, good, because that means you are paying attention. Let me start with what seems obvious. You look around and everything you see has a cause, because a ball rolls when someone kicks it. Rain falls because water evaporated and condensed. And you exist because your parents existed. Cause and effect is so deeply wired into human thinking that most people assume it must apply to everything, including the universe itself. The reasoning is simple. If the universe exists, something must have caused it to exist. That line of thinking led to one of the oldest arguments for the existence of a creator, the first cause argument, which traces back to Thomas Aquinas in the 13th century. Aquinas argued that there must be an uncaused cause sitting at the bottom of the chain, something that started everything moving, and that something, he claimed, is God. For centuries this seemed airtight, because if you keep asking what caused that, you must eventually reach a thing that has no cause. But here's the thing. The argument contains a hidden assumption. It assumes that time stretches back infinitely, that there was always a before, and that asking what happened before the Big Bang is as meaningful as asking what happened before Tuesday. What I spent my career showing is that it is not, and that the question itself is the problem. To understand why, you need to know what we actually discovered about the beginning of the universe, and why those discoveries forced us to rethink the nature of time itself. In 1927, a Belgian priest and physicist named Georges Lemaître predicted, working directly from Einstein's equations of general relativity, that the universe was expanding. 2 years later, Edwin Hubble confirmed it with direct observation at the Mount Wilson Observatory in California, where he measured that distant galaxies are moving away from us in every direction, and that the farther away they are, the faster they recede. Einstein himself had resisted this conclusion. He had inserted a term into his equations, the cosmological constant, specifically to keep the universe static, because the idea of an expanding universe disturbed him. He later called it his greatest blunder, and that detail matters, because even the greatest minds resist truths that challenge their assumptions. Keep that thought. An expanding universe now means a smaller universe in the past. Wind the clock backwards and everything draws closer together. Go back roughly 13.8 billion years and all the matter, all the energy, all of space itself was compressed into a region of unimaginable density and temperature. That is the Big Bang. And it was not an explosion in space, but an expansion of space itself. In the 1960s, Roger Penrose at Oxford and I at Cambridge proved a series of theorems showing that, given the general theory of relativity and reasonable assumptions about the distribution of matter, the universe must have begun in a singularity, a point where the density of matter and the curvature of space-time become infinite. At a singularity, every known law of physics breaks down and simply ceases to apply. That was not a minor technicality. It was a statement about the limits of knowledge itself. If the laws of physics cannot describe the beginning, then the beginning sits outside the reach of science, and it becomes a boundary condition, something imposed from the outside. And that boundary is exactly where people tend to insert God. I was not satisfied with that answer. I held the Lucasian Professorship of Mathematics at Cambridge, the same chair once held by Isaac Newton, and I believe science could do better than surrender at the moment it mattered most. The key was recognizing something that Einstein's general relativity alone could not account for. At scales smaller than the Planck length, roughly 10 to the minus 35 meters, and at times earlier than the Planck time, roughly 10 to the minus 43 seconds after the apparent beginning, quantum mechanics takes over completely. Classical physics alone cannot describe the origin of the universe because you need a quantum theory of gravity. A complete quantum theory of gravity does not yet exist, but we can use what we know to ask what happens to the singularity once you bring quantum mechanics into the picture, and the answer changed everything. In 1983, Jim Hartle and I published a paper titled Wave Function of the Universe, and in it we developed what became known as the no-boundary proposal. The idea is deceptively simple, but what it implies will unsettle you. To understand it, I need to introduce a concept that sounds like it belongs in science fiction, but is in fact standard mathematical physics, and that concept is imaginary time. Do not be intimidated by the name. In mathematics, we use imaginary numbers, which involve the square root of -1, denoted by the letter I. When you replace ordinary time in the equations of physics with imaginary time, something extraordinary happens, because the distinction between time and space disappears entirely, and time becomes just another dimension of space. Sit with that for a moment, because it means that in ordinary time, the universe has a beginning, a singularity, an edge. But in imaginary time, there is no edge, no boundary, and no beginning. The universe is finite in size, but has no boundary, no starting point, and no end. Let me make this concrete with an analogy I used in A Brief History of Time. Consider the surface of the earth, which is finite in area but has no edge. You can walk in any direction and never reach a boundary where the earth ends. You can head north from any point, but when you reach the North Pole, the concept of north simply stops existing. Asking what is north of the North Pole is not a mystery waiting to be solved. It is a question that has no meaning because there is nothing north of the North Pole. The no-boundary proposal says that time behaves in exactly this way, near the Big Bang. You can trace time backward, but when you approach the origin, asking what came before loses all meaning, not because we lack knowledge, and not because something unknowable preceded the universe, but because there was no before at all. Time itself did not exist. Asking what came before the Big Bang is identical to asking what is north of the North Pole, and that means the universe had no beginning in the usual sense. There was no moment of creation, no ignition, no first instant. The universe simply is a self-contained thing that requires nothing outside itself to explain why it exists. Most people, when they first hear this, look for escape routes. They say that imaginary time is just a mathematical trick and that real time is what truly matters. But here's the thing, that objection falls apart when you look at it closely. Consider what real time actually is. You think of it as the time on your watch, the time you experience, the time that flows from past to future. But in physics, the distinction between what is real and what is a mathematical trick is not as clean as you might hope. If a mathematical model makes correct predictions about the observable universe, if it gives you the right answers every time you check, then calling it unreal becomes hard to justify. I take the position I call model-dependent realism, which holds that there is no picture-independent concept of reality, and a model that works is as real as anything we can know. In imaginary time, the universe has no singularity, no beginning, and no boundary. In real time, it appears to have a Big Bang. Both descriptions work as valid models, but the imaginary time description runs deeper, because in it there is no need to specify what happened at the singularity, since there is no singularity to worry about. Let me build the case from another angle, because this idea deserves to be understood from more than one direction. At the subatomic level, particles do not occupy definite positions or carry definite velocities until they are observed, and they exist in superpositions, which are combinations of all possible states at once. A particle traveling from point A to point B does not follow a single path, but takes every possible path simultaneously. And what we observe comes from adding up all those possibilities. Richard Feynman developed this framework, the sum-over-histories approach to quantum mechanics. Hartle and I took Feynman's idea and applied it to the entire universe. Instead of asking which single history the universe followed from its origin to the present, we proposed that the universe has every possible history simultaneously, where each history is a different curved space-time, a different way the universe could have evolved. The probability that the universe sits in any particular state today depends on adding up all the histories that lead to that state. When you carry out this calculation using imaginary time, the histories that contribute the most are those in which the universe starts out very smooth and uniform, which is exactly what the COBE satellite confirmed in 1992, and what the Planck satellite measured with extraordinary precision in 2013. The cosmic microwave background radiation, the afterglow of the Big Bang, is smooth to 1 part in 100,000, And that matches exactly what the no-boundary condition predicts. This is not philosophy or speculation. It is a testable prediction confirmed by observation that should completely restructure how you think about creation. The universe is not a machine that was switched on by some external agent. It is more like a self-consistent mathematical structure that exists because the laws of physics allow it to, and, in a sense, demand it. In The Grand Design, which I wrote with Leonard Mlodinow, I put the point as plainly as I could. Because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, the reason the universe exists, the reason we exist. Many people misunderstand that statement and object by asking how there can be a law of gravity if there is nothing, and whether the law itself needs an explanation. That is a fair objection, and it deserves a careful answer. The laws of physics are not separate from the universe. They are not instructions written on some cosmic blackboard, waiting to be applied. They describe the way reality behaves. And when I say the universe created itself because of the law of gravity, I am not claiming that gravity existed before the universe and then caused it. What I am saying is that the mathematical structure of the universe, the structure describing space-time, matter, and energy, is self-consistent and requires no external input. Gravity is part of that structure, and the universe and its laws came into existence together as a package where you cannot have one without the other. Consider this as well. In quantum physics, true emptiness is unstable. The vacuum seethes with virtual particles flickering in and out of existence, which means that nothing is not the resting state of reality. Nothing is not the default. Nothing is, in fact, the one state the universe cannot maintain. The deeper question may not be how something came from nothing, but why anyone ever assumed that nothing was the natural condition in the first place. People also misunderstand what I mean by nothing. They assume I mean empty space, and I do not, because empty space is already something with geometry, quantum fields, and energy. The nothing I refer to is the absence of space and time altogether, and the no-boundary proposal describes the universe emerging from a state in which space and time did not exist in their usual form, where the distinction between them was blurred by quantum effects, and where the universe was described by a smooth, self-contained geometry without a boundary or an edge. I should say that I was not alone in reaching this kind of conclusion. Alexander Vilenkin at Tufts University arrived at a similar result through different mathematics, describing the universe as quantum tunneling from nothing into existence. In the same way that a particle can tunnel through a barrier, it does not have the energy to cross. Our approaches differ in technical details, but the essential conclusion is the same. The universe requires no external cause. And here is the beautiful part. None of it was random. M-theory, which is the most complete candidate for a unified theory encompassing all the string theories, contains within it the possibility of many different universes, each with different apparent laws, different values of the physical constants, and different numbers of spatial dimensions. The number of possible universes permitted by the equations is roughly 10 to the power of 500, which is more possible universes than there are atoms in the observable universe. Ours, with its particular electron mass, its nuclear force strengths, and its gravitational constant, is one solution among many. Think about what that means for the old question of design. People look at the laws of physics and say they appear fine-tuned to allow life, because if the strength of gravity, or the mass of the electron, or the nuclear forces were even slightly different, stars would not form, chemistry would not work, and we would not be here. That apparent fine-tuning has been used as a teleological argument, an argument from design, going back well before William Paley and his famous watchmaker analogy. But if M-theory is correct, there is no fine-tuning at all. 10 to the 500 different possible universes exist, each with its own set of laws, and most of them do not permit life. We find ourselves in one that does, and that is not evidence of design. Physicists call it the weak anthropic principle, a selection effect. You cannot observe a universe that does not permit your existence, just as it is no mystery that we live on Earth rather than Mercury, not because Earth was designed for us, but because Mercury cannot support life. Let me be clear about what I am claiming and what I am not. I am not saying that God does not exist. I am saying that God is not necessary to explain the origin of the universe, because the universe can account for its own existence without anyone needing to light the blue touch paper and set it going. As early as the 5th century, St. Augustine recognized something along these lines. He argued that time was a property of the universe that God created, and that there was no time before creation. When people asked what God was doing before he created the universe, Augustine did not give the popular answer, which was that God was preparing hell for people who asked such questions. Instead, he said that time itself was part of creation, and the question carried no meaning. The no-boundary proposal takes Augustine's insight and formalizes it in the language of physics. Time is a property of the universe. It began with the universe, and there is no before. This is uncomfortable for many people, and I understand why. Because humans are storytelling creatures who want narratives with beginnings, middles, and ends. We want a moment of creation, a first cause, a reason, and the idea that the universe simply exists, that it is its own reason, that the question of why there is something rather than nothing dissolves once you understand the physics, that feels unsatisfying to a lot of people. But consider what the alternative actually looks like. If you say the universe required a creator, you have not solved the problem, you have only postponed it, because now you must explain the creator. You must answer who created God, and if you say that God needs no creator, that God simply exists without cause or explanation, then you have admitted that something can exist without a cause, at which point you might as well cut out the middleman and say the universe itself is a thing that exists without a cause. At least we have evidence that the universe exists. I am not trying to be provocative for its own sake. I am trying to be honest. Science has a long history of discovering that the universe does not conform to human expectations. The Earth turned out not to be the center of the cosmos. Species were not individually designed. Time is not absolute. Space is not fixed. And reality is not intuitive. The universe does not need permission to exist. In my later work with Thomas Hertog, we took the no-boundary idea even further into what we called top-down cosmology. The conventional view holds that the universe has a single history stretching from the Big Bang to the present, and top-down cosmology says the opposite. The universe does not have a single history. It has every possible history, and we select the one we observe by making measurements today. The present determines the past, not the other way around, and the universe does not carry a history independent of us observing it. This is quantum mechanics applied not to an electron, but to the entire cosmos. That should make you deeply uncomfortable, and I mean that as a compliment. Every time you look at the night sky, you are seeing the consequences of a universe that brought itself into being. The photons reaching your eyes were forged in nuclear reactions inside stars that condensed from gas clouds that formed from matter that emerged from a hot, dense state arising from a quantum geometry in which space and time themselves crystallized out of the no-boundary condition. There is no first domino in the chain. Cause and effect, which you rely on in everyday life, does not extend back to infinity because it terminates in a state where the very concept of cause and effect loses its meaning. The universe did not come from something, and it did not begin in the ordinary sense. The geometry of space-time near the origin is smooth and complete, like the surface of a sphere, with nothing missing and no hole where a creator needs to be inserted. I have spent my career trying to understand the universe, and what I have found is that it is more elegant and more self-sufficient than anyone expected. It does not require a supernatural explanation, only the laws of physics, and those laws, far from being arbitrary rules imposed from outside, are the very fabric of reality itself. That is what the origin of the universe really is. Not a moment of creation and not an act of will, but a self-contained geometry, finite yet without boundary, requiring nothing beyond itself. It is not the answer people wanted, but it is the answer the mathematics gives us. And in my experience, when human intuition and mathematics disagree, it is always intuition that must yield. The universe is not a story with a beginning. It is a shape without an edge, and we are part of it, temporary patterns of matter and energy that are aware, for a brief moment, that the cosmos we inhabit needed no one's permission to exist.